Hello and welcome back to the lab. So we're back to working on the 1946 Jukebox amplifier again today, and we've done quite a bit of work on it since the last episode. So let's take a look. When we left off, I had center punched and began ready to drill a hole to install the indicator light when I accidentally slipped with my center punch and put a big scratch in my brand new red paint job. So I had to repaint it. So I did repaint that. I did drill the hole and I installed the indicator lamp. We've also put on the volume control pot with its associated chicken head pointer knob, and the bass and treble control pots with their associated chicken head knobs. The front panel input jack I was tarnished, and so I spent some time polishing that up and getting it back to normal. I don't have any idea what type of jack this is. It sort of reminds me of a AM car radio antenna connector, but I don't really know what it is. I reinstalled the original input jack, but I'm not going to be using that connector at all because I don't even know what it is. It also has an RCA phono plug input that's wired in parallel. Um, I don't believe this is original to the amplifier. Someone has added it at a later date, but it was original when I received the amplifier. It was installed, so I reinstalled that one as well. We may end up using this as our input. I may even decide to put another input jack altogether. I haven't decided exactly yet. On the top of the chassis, we have the terminal barrier strip, the screw terminals for the external output speaker. Because it's a jukebox amplifier, there's an internal speaker on the jukebox cabinet, and there's also a provision for external speakers for remote jukebox units that you used to see on the tabletops of diners and such like that. You can select your song directly from your table without going over to the jukebox itself to select your song. And there's an external speaker connected in that remote unit, and that's where these speakers are connected. This is the only speaker output we're going to use. Um, it's capable of handling up to four external speakers, four external 8-ohm speakers. And so there is this output impedance selector switch that I repainted that and reinstalled it on the top. And you can select between 8 ohms, 4 ohms, 3 point whatever, and 2 ohms, depending on how many 8-ohm external speakers you have connected in parallel onto the output barrier strip screw terminals here. So that will be our output connector. I may decide to use a different type of output connector that I can drill another hole and install an output jack over here on the front panel as well, if I decide to do that. The internal speaker is connected through this connector, which I also reinstalled. These connectors were riveted originally, and I drilled out the rivets so that I could repaint the chassis, and I reinstalled them with number 440 stainless steel screws to mount those connectors back in place. This connector is for an external remote volume control. If you don't use the internal volume control, you can use this external volume control. Otherwise, it should be jumpered out with a jumper plug, which I don't have the jumper plug. So I can either put a piece of wire into the connector terminals itself, or more likely I will jumper it across in the inside on the back side of this connector to use only the internal volume control. All right, I've temporarily reinstalled all the tubes. I don't know if they work yet. I do know that the rectifier tube works just fine because we already tested that. But I don't know if these other tubes, uh, filaments will light up. So that's why I reinstalled them today temporarily. We'll probably take them out again to continue working on the unit after we test those filaments out today. I've put in all the remaining CAN electrolytic, top-mounted, chassis-mounted CAN electrolytic capacitors. Um, this one in the rear here, which you can't really see in the video, is an original one because I don't have a 3/4 inch diameter replacement CAN capacitor for that one. I will use a modern electrolytic on the underside of the chassis, and I just reinstalled the original 3/4 inch um, CAN capacitor on the top just to take up the hole and to make it look original. Now I do have a 1 inch diameter replacement CAN for that, but in order to use that, I would have to punch a 1 inch hole in the chassis to replace this instead of this 3/4 inch hole that's there now. And I don't think I really want to do that. I don't think I want to make any changes to the chassis because if I mess it up, I can't undo that mistake. So I think I'm just going to leave it the way it is with a 3/4 inch. I reinstalled the output transformer as well and began to do some wiring underneath. So the the top side of this chassis and the front panel of this chassis is pretty much complete now. The only things I have to do left are the name tag with the model and serial number and the manufacturer on it goes here in this place, and there's a plate that goes around the volume and the bass and treble controls, and both of those two nameplates are being reproduced right now. I have a guy that scanned the originals, and he's building reproduction nameplates for those two, and hopefully they should be in soon, and I'll be able to get those mounted on this chassis as well. So in addition to working on the outside, I did some work underneath, and so let's take a look at that now. Okay, so here we see the underside of the chassis. Um, I decided to work on the 6.3 volt filament circuit today to see if we can get all the filaments to the tubes to light up. So here we see the output of the main power transformer. 6.3 volt winding is this yellow colored cloth covered wire right here. I installed a terminal strip to mount those wires to connect to the rest of the 6.3 volt circuit. We have a twisted pair that goes to the pilot lamp socket that I just installed. I decided to put um, a pair of like an artificial center tap for the 6.3 volt filament winding by using a pair of 100 ohm resistors to ground, one from each side of the 6.3 volts to ground, and that's what these 100 ohm resistors are. Originally in the filament circuit on this amplifier, one side of the 6.3 volt winding was connected directly to ground, and the other side was connected to 6.3 volts. So it was just one single-ended, one side of 6.3 volts AC above ground. That's because they also used this 9.5 volt winding also to do the quick start feature that we talked about previously. I'm not going to be using the quick start feature on this amplifier, so I took the 9.5 volt winding and just tied it to the last remaining terminal on the terminal strip and soldered it in place, and it'll just be standing there. That just to give it a place to connect to so it doesn't float around in the chassis, but it won't be used in the new circuit. So instead of having a single-ended 6.3 volt winding, now we have a balanced one with an artificial center tap with 200 ohm resistors to ground. So each side will be floating with respect to ground. That is sort of like a hum balance control to try to minimize the hum. I may want to eventually replace these 200 ohm resistors with a potentiometer to fine tune to adjust the balance to null out any remaining hum in the amplifier. I don't know if we'll need to do that or not, but this is one modification I did to the original circuit. Now, the original circuit did use twisted pair, even though one side of it was grounded. They did use this cloth covered wire it's hard to see the colors, but one wire in the original filament circuit was blue colored, and the other was black with a white stripe. The blue one was actually grounded, connected to chassis ground, and the black with the white stripe was the 6.3 volts that went to each of the filaments. I decided to replace this cloth covered wire with um, solid 18 gauge modern wire. So that's what I did. I took a pair of wires and twisted them. I mounted it in my, chucked it up in my drill and ran the drill for a second and made the twisted pair wire. And then I ran each of the wires from this terminal strip out throughout the rest of the circuit, following the original pattern of wiring. But now neither end of the 6.3 volt circuit on each of the tubes, neither end of them is connected to ground. It's only balanced with respect to ground back here at the power transformer itself. Hopefully that will minimize any hum related to the filaments. Now it was rather difficult routing this twisted pair 18 gauge wire. It's pretty stiff when you have two of them twisted together. It was a lot of work. So I developed a lot of respect for the ladies who originally wired this unit up 80 years ago. Opal, Mildred, Betty, Lee, Thelma, and Dessa. They all signed their names in the bottom of the chassis, and I hope I honored their legacy by doing a good job with wiring up the filaments on this circuit. Now, most of the rest of the circuit hasn't been rewired yet, so I'm not going to worry about that. But I did want to test out the 6.3 volt filament winding, make sure we do have 6.3 volts, and also to make sure that all the tubes do light up. So first we're going to power it up upside down and measure the 6.3 volts and make sure that we do have 6.3 volts. I'm going to see if the pilot light comes on in the front panel. And we're also going to flip it over and take a look at each of the tubes to make sure they light up. Now, I know that the rectifier tube lights up because we tested that already in the previous episode, but I haven't tested any of the rest of these tubes yet, so I will be able to at least see if the filaments are still good in all these tubes, if the heater circuits will work in each of these tubes. And I haven't done that yet. We're going to find out together if I've got it wired correctly. Now, I followed the wiring very carefully, and I double checked it and triple checked it. So I'm pretty sure it's wired correctly, but I'm not positive. And I may have made an accidental mistake, but it's properly fused and everything. So if there are any shorts in here, the fuse will blow, and that will be that. Also, the high voltage is not connected to the tubes yet, but it is functioning and active. So I have to be very careful not to touch the high voltage section of this amplifier once I've got it turned on, and even after I've got it turned off. Those capacitors hold the high voltage charge for a very long time, and I don't want this to be the last project that I ever work on, so I'm going to keep my fingers away from that. All right, so let's plug it in and turn it on and see what happens. Okay, so I have my 3455A hooked up to the high voltage line, so I can monitor that voltage to make sure that I'm not going to get zapped. All right, so I won't be able to touch anything while there's high voltage on that line, on that displayed on that voltmeter. This voltmeter is hooked up to the 6.3 volt AC filament circuit. So we're going to measure the 6.3 volt AC voltage coming out with this meter. I plugged the unit in and I'm ready to turn it on. Now, I haven't done this yet, so I don't know how it's going to work, but we're going to find out together. Here goes. Ready? All right. 6.3 volts is actually reading 6.9 volts. I guess that's okay. It's reading quite high. I think that's because this this amplifier was actually designed for 110 volts, and we're feeding it with 120 volts AC instead of 110. That's why our filament voltage is probably a little bit high. I guess it's all right. Um, I'm glad it's not low because that means that the 18 gauge wire that I used is actually good enough for the amount of current that's needed to be supplied to that circuit. So the 6.3 volts is working, so I don't have any shorts. Here's the high voltage, 587 volts, just like we measured before. I'm still a little concerned about that voltage. It's also way too high, but it's what it is. So that's why I haven't hooked up the high voltage to any of the rest of the circuit yet. In the previous episode, we talked about changing the value of the field coil resistor to reduce this voltage, and that seemed to work pretty well. So that's probably what I will end up doing. But right now, that all of that is just disconnected. I can see on the front panel that the indicator light is lit, the 6.3 volt lamp that I put in place. Let me put the camera back down there so you can see that. Okay, and the amplifier is upside down still, of course, but there's the 6.3 volt uh, pilot lamp, bright red. Very nice. Came out very nice. It doesn't show up as nice in the camera as it does in person. I really like it. Okay, I want to flip the voltmeter over and take a look to see if all the filaments and all the tubes are illuminating to make sure that the tube, at least the filaments, are still good in all of these tubes. So let me do that now. I have to be very careful not to come near the high voltage section while flipping it over. Let me do that off camera. All right. Um, this little wooden jig that I built temporarily, that's not going to be permanently part of the amplifier, of course. It's just so that I can flip it over and work on both sides, the top and bottom sides of this chassis of the amplifier. Came in very handy, and I'm very glad I decided to just slap that together and get this going. I'm going to take it off when the project is complete, of course. It has nothing to do with the amplifier at all. It's just a way for me to work on it. Um, This amplifier, of course, does not have a cabinet any longer. It's going to be a standalone amplifier, just the chassis and the tubes and such sticking out of the top. I think it looks pretty good already, and it should be even a little bit nicer when we're finished. Um, okay, so I've flipped it over, I've plugged it back in again, and I've disconnected the voltmeters from where I had them situated. Now, I want to just take a look and see if all the filaments and all the tubes light up. And I can feel that some of them are, these two are warm, so it must be working. We already know that the rectifier tube works, so, ooh, that's very hot. Yeah. All right, so I'm ready to turn it on now. Let's take a look and see if we can see filaments in all the tubes. The 6L6s, you can see both the filaments lighting up right away. Let's see if I can turn the lights off or down or something. Let me go back here, the other side of the room. Shut off the light. There we go. You can see the rectifier tube over here. Here's the preamp tube. It's lighting up. The intermediate stage tubes, both of those filaments are lighting up, and both of the finals are lighting up. All of the filaments light up. The heaters in all these tubes are working just fine. Wow. Very good. I'm excited. And of course, the pilot lamp, it lights up very brightly. Looks great. Wow. All right. Okay, so that's the 6.3 volt filament circuit on the Packard Pla-Mor amplifier. I think that will do it for this episode. We're going to continue to wire up some of the rest of the components and get some of this circuitry going. And hopefully the next episode we'll get those two nameplates back from that guy who's making the reproductions, and we'll get them installed. And this unit is coming right along. And while recording the video, Hopper has decided that she wants to see what's going on. She decided to climb up in my chair behind me. Oh, she's lost interest, I think. Hey, don't destroy my chair, Hopper. She's my boss. This is the lab manager, Hopper. So that will do it for this episode. There's plenty more work to be done on this amplifier, and I have lots of other projects in the pipeline after this as well. Thank you very much for watching. Please like and subscribe. You know, we're getting very close to 1,000 subscribers to this channel, and that really just amazes me that anybody's interested in watching my little video channel. Thanks very much for giving me this opportunity to share my hobby with you. Please come back for more, and thanks for watching.